Hello lovelies, in this video we're going to be taking you through our AQA GCSE Maths Foundation, the paper one that we've written for 2024. Now, please pay careful attention to how the answers are laid out, how we're going to structure things so we can really show off to the examiners exactly what you know.
Here we're asked to write 2/5 as a decimal. So here there's an important fact that we should really know. We need to know what certain fractions are as decimals. And 1/5 is certainly one of these examples. So we should really know that 1/5 is equal to 0.2. We can deduce from that then that 2/5 is going to be 2 times 0.2, which is going to give us 0.4. So our answer to this question is 0.4. So here we're asked to convert 12.5 millilitres into litres. So it's important here that we remember that 1 litre contains 1,000 millilitres. So here where we have 12.5 millilitres, we need to divide this by 1,000 to find the number of millilitres. So when it comes to dividing a number like this by 1,000, I would recommend putting a load of zeros before the number, just as little placeholders. They don't really mean anything, but it's going to help you visualise this division by 1,000, because we need to move this decimal place back 1, 2, 3 times. And that is going to leave us with 0. So we're going to put the decimal in here, 0.0125. So the answer to this is 0.0125 litres. So here we're asked to simplify 9x divided by 3. So here you can see we've got a mixture of numbers and letters. Now the thing to remember is that you divide the numbers by the numbers and you divide the letters by the letters. So here you can see we have 9 divided by 3 essentially. So we know that 9 divided by 3 is equal to 3. So here then this will end up giving us the answer of 3x. And that x just plonks on the end there because nothing has really happened to that. There were no other x's that we divided it by or timesed it by. So that x just stays put. But we did have to do 9 divided by 3 to find 3. So our final answer for this is simply 3x. So here we're asked to work out 4 times minus 4. So this question is really just testing our understanding of negative numbers. And if we have a positive number like we do here, and we multiply it through by a negative number, we need to know that we end up making a negative number. So here then, I would just do the 5 times by the 4 and get 20. But then I would take into account that it was a positive number times by a negative number, and I would see that I get negative 20. So that there will be our final answer, minus 20. So here we're given a list of numbers given below. We're asked to write the numbers in order of size, starting from the smallest first. So out of these numbers, you can see that one of them is a negative number. Now, if we have a negative number, then that is always going to be smaller compared to the others. So we can start by writing the smallest number is minus 0.01. So now that leaves us with 0.1, 0.01 and 1 as our options that we need to put in order, starting from the smallest first. So here, if we think in terms of place value of these two decimals, here this one is talking in tenths. And here this one of the 0.01 is talking in terms of 100ths. Now 100ths is smaller fraction than tenths. So for that reason, this 0.01 is going to be the smallest of these three. And the next smallest is going to be 0.1, which has the place value of tenths. And then finally the biggest is going to be 1, which is simply in the units. So here we have got the negative number as the smallest, then the number which has its biggest place value as being in the 100ths, and then the number whose biggest place value is in the tenths, and then finally 1, which is in the unit place value. So there we go, there are our numbers in order of size, starting with the smallest first. So here we're asked to find an estimate for 5.01 squared minus 1.01. So there's a couple of things going on. Here we need to know our order of operations, but we also need to know how to estimate something. And when you're asked to find an estimate, you're not actually being asked to calculate the exact value. Of course, this is a non-calculator paper, that would actually be really quite challenging. Here we're just asked to estimate to get a good set of numbers, which are going to give us a good approximation as to the final answer. So here I would round the 5.01 to 5, so instead I have 5 squared, and that's because of course 5 is a whole number which is very, very close to 5.01. Then I'm going to do exactly the same with the 1.01. I'm going to round that to make 1, because again that is very close to the value of 1.01. So what I have here now is a calculation that I can use my orders of operations to work out. Now for the orders of operation, there's a few different phrases that people use. There's BODMAS, there's BIDMAS, there's a load of other ones too, like PEDMAS. I think the most commonly used one nowadays though is BIDMAS. So to remind you with this, you first do your brackets, then you do any indices, which are the same as powers. Then you do any division, any multiplication, any addition, and then any subtraction. So here you can see that the brackets and the indices are going to be the part that we do first here. So 5 squared is equal to 25. And then minus 1, that will end up giving us 24. So here an estimate, 5.01 squared minus 1.01 is 24. So here we're asked to find the gradient of line L. So to find the gradient, we need to use the following equation. So we can work out the gradient by using this calculation where the gradient is the change in the y divided by the change in the x. Now this is such an important equation and we do need to get this memorised. Some people instead prefer to learn it that the gradient is equal to the rise over run. And what all this is really referring to, if we look on the graph, the rise is how high it goes and the run is how far along it goes. So what we would generally do in a question like this is you would find a convenient little triangle that you can sort of sketch out along the line that hits good coordinates. And you see, well, how tall is that? I can see it's 2 tall. And how far along is it? It's 2 along. And then we substitute that in. So the rise is 2 and the run is 2, which means that the gradient is actually 1 because 2 divided by 2 gives us 1. So now that we've got that, we can look at part B, where we need to find the equation of this line now. So here it's important that we know that the equation of a straight line is given by y equals mx plus c. Now this is another equation that you just simply need to know off by heart because it always comes up. So here the m in this equation is the gradient, and the c in this equation gives us the y-intercept. And what that means is the coordinate at which it crosses the y-axis. So on this particular line that we have here, we can see that the point where it crosses that y-axis is actually equal to minus 2. So for this particular line, we've already said that the y-intercept is minus 2, and the gradient we've worked out in part A is 1. So we can substitute these in now to this equation of a straight line to say that y equals 1x minus 2. And because we don't generally write 1x, we normally just write x. It would probably be better, although not essential, to write it as y equals x minus 2. And that there is our equation of a straight line. But my main takeaway from this, what I really want you to know, is we need to have in our memories for GCSE maths this equation for gradient of a straight line, and also this equation of a straight line as well. Because without these, we're going to really find impossible any question about equations of a straight line. Good work though, okay? Get those memorised, stick them on a flashcard. Here we're told that the average temperature in a town called Summertown were recorded and illustrated in a bar chart. If we look at this bar chart though, we can see it looks a little bit incomplete, and that's where the question is going. They want us to write down 2 things that are wrong with this bar chart. So first things first, if we have a look at what we have on this y-axis here, you can see we don't really know what it is. Of course, in the question they told us that we're looking at average temperatures, but we don't know that that is what has been measured. We haven't labelled the y-axis with a title, and we also don't know the units. Is it degrees C? Is it degree Fahrenheit? We have no idea at all. So that's the first thing that we can say. Next, if we look at how we step up on the y-axis, it goes up by 5s until it goes up by 10. And then it goes up by 5 again. So what we have here is we have an irregular y-axis. The y-axis has not got a regular scale, and in fact it jumps from 10 all the way to 20 rather than stopping at 15. So that is a really important error in this graph, and one that we definitely need to write about. So we've got here 2 points. We have got that the y-axis has no title or unit. And then we have also got the fact that the y-axis jumps from 10 to 20, and therefore it does not have a regular scale. So that is our answer. Those are our 2 things wrong with this bar chart. And they're 2 things that could be wrong with any bar chart. So you can take your knowledge from this question and apply it to any other bar chart question as well. Here we're told that xy is a straight line, and we're asked to work out the value of x within this question, and we're asked to give a reason for your answer. Well, as we know that x to y is a straight line, we can use a certain fact that we know about it. So we know that angles on a straight line will always add up to make 180 degrees. So we're going to use that fact to solve this. So if we add up all these angles, 5x plus 2x plus 3x, we can put it equal to 180. So now if we simplify this, we can see they all add up to make 10x equals that 180. Now by rearranging this to get rid of that 10, so if we divide both sides by 10, we end up finding that x is equal to 18 degrees. And that there is our answer. We have worked out the value of x to be 18 degrees, and we gave a reason for our answer by explaining that angles on a straight line will always add up to make 180 degrees. A reel of ribbon has a total length of 5 metres. We're told that a person needs to cut 10 centimetre lengths of ribbon to make some gifts. Here we're asked to find the number of 10 centimetre lengths of ribbon that they can cut from the 5 metre reel of ribbon. So here we've got 2 problems. One is, of course, well, how many of this 10 centimetre fits into the 5 metres? But the other problem is to do with the units. They're not currently consistent. 10 centimetres and 5 metres, they're different units. So we need to convert one of them into the other to make this easier. Now, we know that 1 metre is equal to 100 centimetres. So I'm going to say it's easier to convert 5 metres to centimetres. So 5 metres is going to be equal to 5 times 100 centimetres. So therefore 5 metres is equal to 500 centimetres. Now by doing that conversion, we've already got one of the marks. Now we need to ask ourselves, if we have this length of 500 centimetres, how many of these 10 centimetres will fit within it? And we can work that out by dividing the two. So if we do 500 divided by 10, we end up getting 50. And that is going to be the answer to this question. That is the number of 10 centimetre lengths of ribbon that can be cut from the 5 metre reel of ribbon. Here we're told that a shopper bought a newspaper and 2 cups of coffee. We're told that the newspaper cost £1.20 and 1 cup of coffee cost £2.39. But of course we've bought 2 cups of coffee. We're told that the shopper paid with a £10 note, and we're asked to work out the amount of change that they received. So the first thing that I would do, because of course this is a non-calculator question, is work out what the cost of 2 cups of coffee will be. So there's 2 ways you could do this. You could either multiply that £2.39 by 2, or you could add £2.39 to £2.39, whichever you're the most comfortable with really. So here I'm going to show you how to multiply it. So we start by working out what 2 times 9 is. So 2 times 9 is 18. We're going to carry the 1 by placing it just below and to the right. But we're going to write the 8 underneath that 9 times 2. Next up, we're going to do 3 times 2. Now 3 times 2 is 6. If we add 1 to that, the 1 that we carried earlier, that gives us 7. And then we'll put the decimal place in the same position as it was in the £2.39. And then we're going to do 2 times 2. And that gives us 4. So the cost of the 2 cups of coffee is £4.78. So now we need to think, well, how much do we spend in total? So we've paid £4.78 for the 2 cups of coffee, but we've also bought a newspaper. So if we add those 2 numbers together, we will get the cost that we've spent in total. So 8 plus 0 gives us 8, 7 plus 2 gives us 9, put the decimal in the same place, and then 4 plus 1 gives us 5. So in total there we have spent £5.98. So we're told that we paid with a £10 note. So we need to ask ourselves, how much are we going to have left if we spend £5.98? So this means that we need to subtract £5.98 from £10. Now, because this is non-calculator, we're going to have to do this the proper old-fashioned way, okay? So we start on the right and we move towards the left as we go. We'll start by doing this subtraction here. 0 minus 8. Now we can't do that, can we? Because we can't take 8 away from 0. So that means we need to look to the left and see if we can take 1 from the left-hand side. Well, the left is 0 as well, so we can't take from that either. So we need to look here. Oh, still 0, can't take from that. So we need to look to the next one before we actually get a number that we can borrow 1 from. And by this point, we're actually taking from 100. So if we take 1 from 100, then we end up instead having 99. And we've borrowed 1, so the 0 over on the right-hand side becomes a 1. So now we've got something that we can do, okay? So now, starting again, let's do this time 10 minus 8. So 10 minus 8 is 2. Then, moving towards the left, let's do 9 minus 9. So 9 minus 9 is 0. Now let's put the decimal place in the same position as it is with the £10 and the £5.98. Next up, we're going to do 9 minus 5. 9 minus 5 gives us 4. And moving further to the left, there was a 1, but we borrowed that 1 to do the earlier parts of the question. So for that reason, this is our final answer. The amount of change that they received is £4.02. So here we're told that a sequence is made from tiles. We're asked to draw the 4th pattern in the sequence. So looking at each sequence here, you can see that as we go from one term to the next, we add on an extra 3 squares. But we're alternating whether we're adding the white squares or the black squares. So now that with n equals 3, we can see that we added black squares. That means that when we do the 4th pattern, the n equals 4 pattern, we're going to want to add some white squares now. So I would probably start here just by copying out what we see n equals 3 to be. So I can see that there's 7 squares along the bottom and it is 4 squares high. So we don't have to do these particularly well or fancy or to scale or anything. They can be quite awkward to draw really. But the n equals 3 term, 3rd term, looks something like this. So in order to make the 4th term, we need to add a square onto each of these points. And these need to be white squares because we're alternating. So adding those squares on is going to give me this pattern here. So for B now, we're asked to complete the table, which means that we need to complete the number of white tiles, black tiles and total tiles in the 4th pattern of this sequence. So I can see, looking at the little diagram that we drew, that in terms of white tiles, we have 1, 2, 3, 4, 5, 6, 7. So I'm going to fill in the white tiles with 7. Then at the same time, if I look at the number of black tiles, see I have 1, 2, 3, 4, 5, 6. So I have 6 black tiles. Now to work out the total number of tiles, that is just the white tiles plus the black tiles. So that means that we have 13 tiles in total. So now we're asked to find an expression in terms of n for the nth term of the sequence for the total number of tiles. So if we look over at our table here, that means we're looking at a sequence for these numbers here. So we want a sequence for the numbers 4, 7, 10 and 13. So to do this, let's have a look at what the common difference is. How much is it going up each time? I can see here that it is going up by a regular amount each time. It is going up by 3. So when we're finding the nth term of a linear sequence like we have here that's going up by a regular amount, once we find that common difference, we multiply it through by n. Then we need to do one last thing to be able to finish this nth term. We will have a look at what was the first term and we're going to this time go back by 1. So instead of adding 3 when we went forward, we're going to subtract 3. So 4 minus 3 gives us 1. So because we got 1 there, and that's positive 1, finish off our nth term, we're going to add that 1 onto the 3n, and that there gives us our nth term. So that's a really handy trick. So we get the common difference and multiply it through by the n, and then if we go backwards from that first term just once and see what term was in the past, we plonk that on and then we have 3n plus 1 in this case. So for part D here, we're asked to work out the total number of tiles in the 10th pattern of the sequence. So that means we need to know how many tiles there are when n is equal to 10. Now we have the nth term is 3n plus 1. So if we want to work out the total number of tiles when n equals 10, we substitute in place of the n 10. So here we're going to get 3 times 10 plus 1. And that gives us 31. So in answer to the question, what is the total number of tiles in the 10th pattern in the sequence? Our answer is 31. Here we're told that a class did a maths test and their scores are given below. Here we're asked to find the median score. Now median refers to the middle. And in order to find the median here, we're going to have to write these numbers in numerical order, starting from the smallest going up to the biggest. So as we do this, we look at the list and we're going to write down the smallest number. Cross it out now. Next one's 48. The next one's 49. The next one's 54, so we'll cross that one out. The next one's 55. And then the next one's 60. And then after that, it's going to be 65. And then we have two 66s to finish us off. It's important that we cross these out as we go, or we're just going to write down the same thing twice. So notice here that we have 9 numbers. So to find the middle one, the easiest way to do it is to cross one out from the beginning and then one out from the end, and then move in again. So beginning, end, and then again, beginning, end, again, beginning, end, until you end up with a value in the middle. So in this case, that middle value is the median, and that is 55 in this case. So the median score is 55. Then for B, we're asked to find the mean score. So the mean score involves us adding up all of the numbers and then dividing by how many numbers there are. So that's generally written as the mean equals the sum divided by n, where n is how many numbers there are. So here I'm going to get all these numbers back again so that we can see them. And now we're going to add those together. So here that means we're going to do 55 plus 54 plus 48 plus 65 plus 66 plus 49 plus 32 plus 66 and then plus 60. And we're going to divide all of those through by 9. So in the end then, let's add up the top bit, and I make that to be 495, which we want to divide by 9. So just a little reminder as how to divide 495 by 9. You're going to ask yourself, how many 9s go into 4? Well, no 9s go into 4. So then you'll ask yourself, how many 9s go into 49? And 5 9s will go into 49. In fact, 5 9s gives us 45. So that means we're going to get a remainder of 4, which will carry on. And then now we need to ask ourselves, how many 9s go into 45? Well, we just worked that out, didn't we? It's 5. So in the end here, the mean is going to be equal to 55. Now 55 is going to be our mean then, and also our median in part A. And then that is our final answer. So here we're told that 5 people took 10 days to decorate a house. And we're told that if we had 20 people instead, can we find out how many days that would take to decorate? And the important thing to notice here is that this is an example of inverse proportion. And inverse proportion means that as one value gets bigger, like in this case the number of people decorating, another variable is going to go down. So in this case, the amount of time it takes is going to go down. So if we think, well, how many times bigger has the number of people got? I can see that it has got 4 times bigger. And in inverse proportion, they're not going to go up by the same factor. In fact, as one gets 4 times bigger, the other one will get 4 times smaller. So we need to work out what 10 is divided by 4. And 10 divided by 4 is 2.5. So it's going to take us 2.5 days to do this. And there's your answer. A shop sold t-shirts, shorts and skirts. In August they sold them in the ratio of 5 to 6 to 2. We're told that 2/3 of the total number of t-shirts that they had in stock were sold in August, leaving behind 15 t-shirts. Here we're asked to find the number of shorts and skirts sold in August. So I would start this by writing down the ratio and labelling what each part of the ratio corresponds to. So here, the 5 parts of the ratio corresponds to the t-shirts, 6 parts corresponds to shorts, and 2 parts corresponds to skirts. So we're told that 2/3 of the total number of t-shirts they had in stock was sold in August. So that means that if we sold 2/3, then we have 1/3 of those original number of t-shirts remaining at the end. So here then, because we know that we had 15 t-shirts remaining, then we know that 1/3 of the t-shirts is equal to 15. So here we're being asked about things sold. So if we have 1/3 remaining of the t-shirts, then that means we must have sold 2/3 of our stock. And if 1/3 equals 15, then 2/3 equals double 15. So if we do 2 times 15, we'll work out what those 2/3 corresponds to, and we get 30 here. So that means that the 5 parts of the ratio for the t-shirts equals 30. Now if we did 5 times 6, that's how we got to that 30. So if everything else in this ratio we also multiply through by 6, we will find out the number of shorts and skirts sold in August. So here I find that we had 36 shorts sold and 12 skirts sold. And that there is our answer. Here we're told that a bag contains 80 balls in total. We're told that 16 of the balls are red and the rest are blue. Here we're asked to work out the ratio of red balls to blue balls in the form 1 to n. So if we have 80 balls in total, and we know that they're either red or blue, if we subtract from the 80 that total number of balls, the number of red balls, then we would be left with the number of blue balls. So 80 minus 16 gives us 64. So we know in this question that we have 64 blue balls. So we're asked here to do a ratio of red balls to blue balls. Now we know that we had 16 red balls, so we'd write that underneath the red. And the blue balls are 64. So we've got a 16 to 64 ratio here. But we're asked to write it in the form of 1 to n. So in order to work out what that n is, we're going to need to divide both parts of this ratio by 16. And the reason why we do that is 16 divided by 16, of course, gives us the 1 that we want as part of this ratio. And then we'll find out what n is here. So 64 divided by 16 gives us 4. So the answer to this question, the ratio of red balls to blue balls in the form 1 to n, is 1 to 4. Here we're told that temperature can be measured in degrees Celsius or Fahrenheit. The graph below helps us to convert between them. We're told in part A that the temperature is 100 degrees Fahrenheit, and we're asked to find the temperature in degrees C. So here all we need to do is to use a ruler to draw a horizontal line at 100. So to do this we need to use a ruler, and we want to line it up at 100 and then draw a nice horizontal line across at that point until it reaches the line. And then at that point where you reach the line, you will then read down vertically to the x-axis. And then what you want to do there is read off the number that you get on the x-axis. So here I can see, looking at the scale, that I have 38 degrees C here. So in part B, we're told that the temperature is now 46 degrees C. And if we have a look at where that would be on this graph, you can see that it's beyond where this line is. So what we would need to do in a question like this is, again, to get our ruler out and to line it up along that line and extend the line. So now that we've done this, we can indeed do just like we did before, but this time we're going to use a ruler to draw a vertical line up from 46 degrees C. So here we can draw a nice vertical line up, and now we can go across horizontally to find the Fahrenheit. And here, reading that, I make that to be around 115 degrees Fahrenheit. But you will find in an exam they're going to give you a little bit of leeway with that. The most important thing is that you show all of your working on the graph and that you use rulers in order to draw these lines. In a school, 1/3 of the students drive to school, 20% of the students cycle to school, and the rest of the students walk to school. Here we're asked to find the fraction of students that walk to school. So let's summarise what we know. So we are told here that 1/3 of the students are going to drive to school. We're also told that 20% of the students will cycle to school. Now we want that as a fraction because we need the answer in a fraction. And we should know that 20% is equal to 1/5. That should just be a fact that we know. Now if we add that 1/3 to the 1/5, then we've got all of the other options added together nice and tidy that aren't walking. So 1/3 plus 1/5 are the people who don't walk. Now to add these we need a common denominator. So the easiest way to do that is to get these in terms of 15ths. So 1/3 will end up becoming 5/15ths and 1/5 will end up becoming 3/15ths. Now once we've got that common denominator, we can simply add these fractions just by adding the top numbers, the numerators, and leaving the denominators as they are. So 5 plus 3 gives us 8 over that 15. So now we need to find what fraction of students walk. So walking is the only other option available here. And we should remember the fact that all probabilities will sum to 1. So because of that, if we take 1, which is the sum of all of the options, and subtract the 8/15ths, which is essentially the fraction or probability of students who are not walking to school, then we will end up having the fraction of students who do walk to school. So to do this, we still want that common denominator. So let's convert 1 whole into 15ths, and that will simply be 15/15ths. So if we do 15/15ths minus 8/15ths, the same rule applies as if we add fractions. If we've got the same denominator, then we are simply going to subtract the numerators on the top and leave the denominators the same. So here 15 minus 8 gives us 7, and that's going to be over 15. So in answer to the question, the fraction of students that walk to school are 7/15ths. So here we're given a calculation. We're told that 546 times by 98 equals 53,508. And we're asked to use this calculation to help us answer the following questions. Because of course this here is a non-calculator question, isn't it? So we can't be expected to actually times these together, although you could if you were very good at that. These are only 1-mark questions, so it wouldn't really warrant the effort. So the way that we need to do it is we need to compare our 546 times 98 to the numbers in this question. And we should be able to tell that the 0.546 is 1,000 times smaller than 546. And over here, we should be able to tell that the 98,000 is actually 1,000 times bigger than the 98. So that means if we were to look at our final answer here, we need to both simultaneously divide that by 1,000, but then also times it by 1,000. And that actually gets us back to square one. So that means that the answer to this problem is actually 53,508. So that is our answer to part A. So our next question is a little bit different, but let's still remember that 546 times by 98 is equal to 53,508. Now what we can see here is that what we've got here is similar. It's like a rearranged version. So if we were to rearrange this equation, we would find that 546 is equal to 53,508 divided by 98. So let's take this step by step. In this question, we don't have 53,508. Instead, we have 5,350.8. Now, if we imagine that this was just divided by 98, so we're just doing this one step at a time, we can see that that number is 10 times smaller. So if that number on the top there is 10 times smaller, then we're dividing a smaller number by 98, and our outcome will also end up being 10 times smaller. So we get 54.6. However, we haven't quite finished here, because instead of dividing by 98, we have to divide by 0.98. Now that means what we want to do is take that 5,350.8 and instead of dividing it by 98, you want to divide it by a number that's 100 times smaller. So that's 0.98. Now the thing to remember is if you divide by a smaller number, you're going to get a bigger outcome. Like imagine you're sharing some money between fewer people. You're going to get more money each. So because on this denominator, we're dividing the denominator by 100, that's actually going to have the effect of multiplying our answer through by 100. So whereas on the previous step it was 53.6, here it will be 5,460, because that is taking the 54.6 and timesing it by 100. So let's just remind ourselves of that. Instead of dividing by 98, we divided by 0.98, which is 100 times smaller. So we're dividing our number by something 100 times smaller. As a result, we get an answer which is 100 times bigger. And finally here we're asked to work out 547 times by 98. So what we need to notice here is we know that 546 98s equals 53,508, but we just want an extra 98. We want another one of them. We want 547 of those 98s. And so that will be 53,508, but plus 98. And because this is a non-calculator, the way we would add this is we would say, what is 8 plus 8? Gives us 16. What is 0 plus 9 plus the 1? That gives us 10. What is 5 plus that 1? That is going to be 6. Then we've just got the 3 and then the 5. So the answer to this question, what is 547 times by 98? It will be 53,606. And there's our answer. So here we're asked to work out 9 times 10 to the 5 times by 3 times 10 to the 7 and to give our answer in standard form. Now here, of course, this is non-calculator, so we need to think about this carefully. The way that I would recommend that we do it is we take our numbers, so the 9 and the 3, and we multiply those together first, and then we take our powers and we multiply those together next. So I'd separate the number bits from the indices. So 9 times 3, nice and easy, should just be 27. So when timesing the indices though, we must remember our index rules. So if we have something to the power of m, for instance, times by something to the power of n, the way that we can simplify that is just by adding those indices. So here in this case, we've got 10 to the 5 and we want to times it by 10 to the 7. It will end up being 10 to the power of 5 plus 7, which is 10 to the power of 12. So here then, we could say that we have 27 times 10 to the 12. Now that's good, But that isn't all of our marks. That's going to just get us 1 mark. Because when we want an answer in standard form, we have to remember that means we need it in the form of a times 10 to the x, where a has to be bigger than or equal to 1 and less than 10. So for that reason, we've got this 27 times 10 to the 12. 27 is too big. We need to bring it down a notch. So we need to divide that by 10, which will give us 2.7. Now to do that, we need to do the opposite to the times 10 to the 12. We need to make that 10 times bigger. And that has the effect of turning the times 10 to the 12 to times 10 to the 13. We just add 1 because we're just adding 1 more 10. So our final answer here is 2.7 times 10 to the 13. So now we're going to use a similar approach here, but we've got a division. So we've got here 1.5 times 10 to the minus 3 divided by 2 times 10 to the minus 7. And here I would recommend we do it exactly the same. We do our numbers first, and then we do our indices. So if we do 1.5 divided by 2, we will get 0.75. And just in case you're unsure how, you could do it this way. So 1.5 divided by 2, you'll say how many 2's go into 1? We get 0, put the decimal in, carry the 1. How many 2's go into 15 now? I can say that 7 go in, remainder 1, because 7 times 2 gives me 14. So I've got 1 remainder in getting up to 15. And then how many 2's go into 10? 5. So that's where we get our 0.75 from. Next up, we will do it with the indices. Here we've got a division, so we need to remember our rule that if we have x to the m divided by x to the n, we subtract those powers. So we've got x to the m minus n. In this case, we have 10 to the minus 3 over 10 to the minus 7, which will end up giving us 10 to the power of minus 3 minus minus 7, which gives us 10 to the power of 4. Because minus 3 minus minus 7 is the same as minus 3 plus 7. So we've got 10 to the power of 4. So putting all of these together, I get 0.75 times 10 to the power of 4. Of course, here again, that doesn't obey our standard form rule because 0.75 is too small. So for that reason, we need to bump it up and we're going to times it by 10, which gets us 7.5. We need to do the opposite to the other bit though, so we need to divide that by 10, which means taking one of those 10's away, which gives us times 10 to the power of 3. So our answer to part B is 7.5 times 10 to the minus 3. So here we're asked to work out 2 3/4 divided by 2/3. Now this question here is about division of fractions. And when we divide fractions, we must remember the KFC rule. KFC. What this tells us is we need to keep the first fraction the same. We want to flip the second fraction, and we want to change the sign from a divide to a times. So it is the keep it, flip it, change it rule, KFC. So we can apply that to what we have here. So we are going to keep the first fraction the same. We are going to flip the second fraction, so it becomes upside down. And we're going to change the divide to a times. So already by doing that, we will likely have a mark. Next up, we need to deal with this mixed number. We need to turn it into a top-heavy fraction. So to do that, we are going to multiply this 2 together with a 4, and then we're going to add the 3. So we're going to do 2 times by that 4 plus 3, and it's all over 4 still. The reason why we do that action is because each one whole is equal to 4/4. So if we had 2 wholes, that would be equal to 8/4. So that's why we did the 2 times by the 4. That was like a little shortcut to get our 8/4. And then to those 8/4 we have to add the 3/4. So we've got this now. So let's simplify it. So 2 times 4 gives us 8, plus 3 gives us 11/4. We're going to times by 3/2. So by changing that mixed number into a top-heavy fraction, we are now going to have another mark for our method. So finally, we need the answer. And to do this, we need to remember how to multiply fractions together. And when we multiply fractions, we simply multiply the tops together and multiply the bottoms together. And that is it. So here we're going to end up getting 33/8. Now looking at the question, it doesn't say that we need to give this as a mixed number or a top-heavy fraction. So we can give it as either. So either we could give our answer as 33/8, or we could change it to a mixed number. If we wanted to do that, we would ask ourselves, how many 8s go into 33? So we know that 8 times by 4 equals 32. So for that reason, we could write 33/8 is equal to 4 wholes, and then we have a remainder of 1 to get to the 33. So it's 4 wholes and 1/8 is the same as 33/8. Now either of those would be acceptable. In an exam, I would probably just leave it as 33/8 if they haven't specified how they want it, because why spend any more time for no extra marks? Here we have a 10-sided shape called a decagon. We're asked here to work out an interior angle of the regular 10-sided shape. So here, the way that we would do this is we're going to work out the sum of the interior angles by using a certain equation that I would recommend that you learn. It's a really, really handy one. It states that the sum of interior angles is equal to 180 times by n minus 2. Now in this case, because it's a 10-sided shape, n is going to be equal to 10. So we can use this here to say that 180 times by 10 minus 2 is going to give us the sum of our interior angles in a decagon. So 180 times by 8 is what we need to work out. Let's do that. 180 times by 8. So here let's start with 0 times by 8, which gives us 0. Then let's have a go at doing 8 times 8, which gives us 64. So let's carry the 6 and put the 4 down here. And then we do 1 times by 8, which gives us 8, but we need to add on this 6. So 8 plus 6 gives us 14. So the sum of our interior angles is 1,440 degrees. Now, because we have a decagon and that has 10 sides and 10 angles, we can work out what one of those interior angles is by taking that 1,440 and dividing it by 10 quite simply. And that will give us 144 degrees. And there's our answer. So here we're asked to increase 350 by 35%. Now, in this particular question, of course, we're in a non-calculator question. So we need to be careful here and we need to use a specific method to do this, which is different to how we might have done it if it was a calculator paper. So I would probably start by working out what 10% of 350 is. And we do that simply by dividing through by 10. So 10% will simply be 35. Next up, I would work out what 5% is, and I can do that quite easily just by halving the 10%. So I'm going to halve the 35 now, and I'm going to get 17.5. Again, if I was unsure how to do that, I would divide the 35 by 2. I would say how many 2's go into 3? I know 1 does, with a remainder of 1. I'd say how many 2's go into 15? I would say 7 do, because 2 times 7 gives us 14. I'd add on a 0.0 because I need to carry the remainder of 1 here. And I'd put the decimal on the top as well. And then I'd say how many 2's go into 10? So I'd get 5. So then that's where the 17.5 comes from. So now we know what 10% is and we know what 5% is. We're well on our way to working out what 35% is. Because we can say that 3 times 10% gives us 30%. So if we do 35 times by 3, we will now know what 30% is. So in doing this, I would say, what is 5 times 3? I know that's 15. I'm going to carry the 1 and write 5 underneath it. Next up, I'm going to do 3 times 3. I'm going to add 1 to that. So 3 times 3 is 9, and I'm going to add 1 and get 10. So I know 30% is equal to 105. So finally we want 35% though. So we'd get that by taking the 30% and adding the 5%. So that's going to be 105 add 17.5. So by doing this, I'm going to say, what is 0 plus 5? That gives me 5. What is 5 plus 7? I know that that is 12. So I'm going to write down the 2 here and carry the 1. Next up, I will do 0 plus 1 plus another 1, which gives me 2. And finally on the end here, I just have a 1 on its own, so I'll just write down 1. So now we know what 35% is, we can increase 350 by 35. So we do that by adding 350 and 122.5 together. So here 0 plus 5 is going to give us just 5. We'll fill in the decimal in the same place. 0 plus 2 gives us 2. 5 plus 2 gives us 7. And 3 plus 1 gives us 4. So our final answer here is 472.5. Done. So here we're told that we're given a fair spinner which is divided into 4 equal sides, A, B, C and D. A student spins the spinner 150 times, and these are the results. We're asked to work out the relative frequency on landing on an A. So the relative frequency is a bit like the probability. What we want to do is say, how many times do we land on an A out of the total number of times that we spun it? So here in this case, we have 46 out of 150. And we could simplify that down a bit to 23 out of 75, but we haven't been told we have to give it in its simplest form. So either of those would get us the answer in the exam. Next up, we're asked to write down the theoretical probability of landing on an A. So the theoretical property comes down to what we know about this spinner and the fact that we know it's divided equally into 4 equal sides. So theoretically, we would expect there to be a 1 in 4 chance of landing on A. So 1/4 is the theoretical property of landing on an A. Next up, we're told that the spinner was then spun 1,000 times and the results were recorded. We're asked to compare the relative frequencies of landing on A that are observed in this case, when the spinner was spun 1,000 times, versus the theoretical probability that we said was 1/4. So we're looking at A again. So the relative frequency in this case is going to be equal to 245 out of 1,000. So if we write that as a decimal, that would be 0.245. So on the other hand, that theoretical probability was equal to 1/4, which we could say is 0.25. So what we can say here by comparison is that the relative frequency of getting an A is very, very similar to the theoretical probability of getting an A. And that there's the little conclusion that we need to make. And talking more generally here, just me to you, we should know that the more times we spin something or the more times we try something out, the closer our relative frequency will be to the theoretical probability. And that is why initially we got an answer that wasn't quite as close in part A. The relative frequency wasn't quite as close as the theoretical probability because we'd only spun it 150 times. But the more times we do it, the closer and closer and closer that relative frequency will end up getting to the theoretical probability. But that's the knowledge that we want to take away from this question for future questions. Here we're told that a carpenter is making a wooden box. We're told that the cost of the wood that they're using costs £0.15 per centimetre squared, and we're asked to find the amount it would cost to make this box. Now if we look at this diagram of the box, you can see we're given all of its dimensions in centimetres. So this should be fairly straightforward. What we're going to need to do is to work out the surface area of the box, and then once we know the surface area, we can work out the total cost of the wood. Because we know that 1 centimetre squared is going to cost us £0.15. So let's get started. So let's start here by working out the surface area. So there's 6 faces to this cuboid. And if we start by taking the front face, which is the same as the back face, to work out the area of that front face, it's going to be 7 times by 20. And of course it's there at the back as well. So we're going to do 7 times 20 and then we're going to double it because of course there's 2 of these faces, at the front and at the back. Next up, let's work out the side. Okay, so this here, if we look at its dimensions, are going to be 10 by 7. So the area of each of those is going to be equal to 7 times 10, and then we're going to double it to account for both of the sides, both the left and the right sides there. Very important that we remember that there's 6 faces to this, not just what we can see. So now finally, let's do the top and the bottom. So if we work out the area of that top, you can see that's going to be the 20 times by the 10. And so to work out the area of that face, we're going to do 20 times by 10, and then we're going to double it to account for the fact that it's at the top and the bottom here. Once we've done all of that, let's work out the area, and it might be easier to do it bit by bit because of course this is non-calculator. So 7 times 20 is going to give us 140, times by 2 is 280. Then over here we've got 7 times 10, which is 70, times by 2 will be 140. And then over here we have 20 times 10, which is 200, times by 2, so that is plus 400. So if we do 280 plus 140 plus 400, that will give us 0. 8 plus 4 plus 0 is going to give us 12. So we're going to carry the 1 and put a 2 down here. And then if we now do 2 plus 1 plus 4, that gives us 7, plus the 1, that gives us 8. So that means that our total surface area is 820 centimetres squared. So we know that 1 centimetre squared is going to cost us 15 pence, £0.15. If we have 820 centimetres squared, then that's going to be 820 times by 0.15. So we're going to need to work out what this is. Now, of course, this is non-calculator, makes it a little bit harder. 0.1 though is the same as working out 10% of something, or 1/10. So what we could do is we could work out what 1/10 of this is, which would quite easily be 82, which we simply get by just dividing 820 by 10. And then we can work out what the 0.05 is, which is the same as 5%, which is the same as 1/20th. And we get that simply by halving the 82. So that's going to give us 41. So using that method, we can add these two together now to get 123. So the answer to this will be £123. And that's one way in which we could calculate it. Of course, there are other ways too. That's quite a good solid method though to get the £123. Let me show you another possible method though, just so that you've got all of the bases covered here in case that didn't quite make sense. If we times 820 by 15, which is clearly here in this number, 15, we can do that quite simply. We can say what is 0 times 5? That gives us 0. What is 2 times 5? That gives us 10. And finally, what is 8 times 5? That gives us 40. Plus the 1, 41. Now let's have a go on to the tens. So we're going to put a little 0 down here. And then now let's do 1 times 0. Of course, that gives us 0 again. Then we're going to do 1 times by 2, which is going to give us 2. And then finally here, we will do 8 times by 1, which is going to give us 8. So adding these together, we get 0, 0, 3, 12. So 12,300. Now that was when we times 820 by 15, but we didn't, did we? We wanted to times it by 0.15. And if you compare 15 and 0.15, you can see that the decimal has moved along twice. It's like once, twice. So if we take our answer here and we do the same, we say, okay, 2 decimal places shift. Go 1, 2. We will again get £123. So I just wanted to show you 2 different ways that we could calculate that, because of course this is a non-calculator paper. It's always good to have more than one method up your sleeve in case you just get brain locked on one of them. But good work. That will be how we work this one out and get a good easy 4 marks, I think. Here we're told that we have a sports day and a student was running the 100-metre race and the relay race. We're told here that the probability of winning the 100-metre race is 1/4. And we're also told that the probability of winning the relay race is 1/3. So we're asked to use that information to fill in the tree diagram below. So straight away we know that the probability of winning the 100-metre race is 1/4. So here, next to the win, I'm going to write 1/4. Then we need to work out the probability of them not winning. So to do this, we need to know that all probabilities of all the options of something happening have to add up to make 1. So for that reason, we can say 1 minus 1/4 will be equal to the probability of not winning. So we need to subtract 1/4 from 1 whole. You may know this straight away, but if not, we can convert 1 whole to 4/4 or 4 quarters, and then subtract 1/4 from that. And whenever we add or subtract fractions, we keep the bottom the same, but we add or subtract the top. So here we're going to do 4 minus 1 on the top, which gives us 3. So here we have 3/4 is the probability of not winning. So now for the relay race, we're told that the probability of winning the relay race is 1/3. So if we look to the right-hand side here, you can see that we have the relay race, and we've got a couple of options for them winning. So under each of those, I'm going to write that 1/3 that we were told is the probability of us winning. But then again, we need the probability of us not winning. So again, we're going to say 1 because we either win or we don't win. And then we're going to subtract 1/3. So in order to subtract this here, let's convert 1 whole into thirds. So 1 whole would be 3/3. And then we need to subtract the 1/3 from that. So again, like we said before, when we're adding or subtracting fractions, we keep the bottom the same, then we add or subtract the top. So 3 minus 1 is going to give us 2. So here we get 2/3. Perfect. So that there is our tree diagram completed. Next up, we're asked to find the probability of winning both races. So if we're going to win both races, that means we need to win the first one, and then we need to win the second one. And in these tree diagram questions, what we need to do as we go along the branches is we're going to multiply those probabilities together. So here you can see we've clearly gone along the branches. So we're going to multiply 1/4 by 1/3. And here when we multiply fractions together, we multiply the tops and then we multiply the bottoms. So here we're going to get 1/12. And that there will be the probability of winning both races. So here we have a vectors question, and we're told that vector A is equal to this column vector 2 minus 4. And we're asked to draw A on the grid. So what we need to understand is that the top part of this vector tells us what's happening in the x direction, whereas the bottom part of the vector is telling us what's happening in the y direction. Now this vector A we can draw at any starting point on this grid. It doesn't really matter so long as you can fit in the whole vector. So let's imagine we start here. So looking at the column vector, I know I'm going to have to go 2 along in the x, and then because the y is -4, that means I'm going to go down by 4. So now I've got the beginning and my end. So I'm going to draw my vector going from the beginning to the end of that journey. And so this purple line that I've drawn here represents that vector 2 - 4. So now we're told that vector B is given by B equals -2, 3 in column form, and vector C is given by C equals -1, -1 in column vector form. And we're asked to find A minus B plus 2C. So I'd probably do this in a couple of steps. Let's first work out what A minus B is. So A is 2 - 4, and B is -2, 3. So what we have got here is the subtraction of 2 column vectors. Now we need to know that we'll do this by subtracting across, and then subtracting across again for both the x's and the y's. Okay, so if we start with the top part of that column vector, we can see that we've got 2 minus -2. And on the bottom, we've got -4 - 3. So what this will end up giving us is 2 minus -2 gives us 4, because a minus and a minus makes a plus. And -4 - 3 is getting more and more negative. So that's going to be -7. Next up, let's work out what 2c is. So we need to do 2 times the column vector of -1, -1. And when we multiply column vectors by whole numbers like this, we're just going to multiply both the top and the bottom of it by that number, so by 2 in this case. And that will give us the column vector -2, -2. So finally, looking at this, you can see that we wanted what was our A minus B, which we found to be 4 - 7. And we want to add to that what 2c is, which is -2, -2. So just the same as the subtraction here, we're going to add across. So we're going to add the 4 to the -2, and we're also going to do -7 add -2. So 4 plus -2 is just 4 - 2, which is 2. And -7 plus -2 is going to be -9. So in the end here, our answer is 2 - 9 in column vector form. So here we have a nice little simultaneous equation question. So in a simultaneous equation question, we need to solve for x and y. We need to get both of those at the end. And the x and y are going to be the same in both equations, so we need to find a way to work out what that is. There's 2 ways, there's elimination and substitution. I generally like elimination, which is where we try to add or subtract these 2 equations to each other to make one of the letters just go away. Now to do that, we need to have either the x's or the y's to be the same as each other. And I can see we have that here. Both equations just have y. Y and y, they're the same. So because both of these are positive y's, I like to tell myself that if I have the same sign, then I need to subtract. Same sign, subtract. So I'm going to subtract these equations from each other. So I'm going to start by saying, well, what is 2x minus 3x? Well, 2x minus 3x leaves us with just minus x. Y minus y is, of course, 0. That's the whole reason why we're doing this. And then we need to ask ourselves, well, what is 8 minus 11? And 8 minus 11 gives us minus 3. So here I can see that minus x equals minus 3, and therefore we can say that x is equal to 3. So we've already got our first part of the answer. Next up, we need to find out what y is in this simultaneous equation question. And to do that, you need to go back to one of the equations that are above. Either will be fine because it will work for both of them. Here, let's choose the first one. So we know that 2x plus y equals 8. And what we want to do here is substitute the 3 in place of the x, because x is 3. So here we'll say then that 2 times by 3 plus y equals 8. 2 plus 3 we know equals 6. So here we have 6 plus y equals 8. And rearranging this to get the y all on its own, we need to subtract 6 from each side. So 8 minus 6 is going to give us y is equal to 2. So our answer to this is that x is equal to 3 and that y is equal to 2. So this is a tricky one. So here we're told that ABC is a right angled triangle, and we're asked to use trigonometry to find the angle of x. So what we need to do here is remember our soccer toa. So we've got so, ka, toa. So at the minute, you might be looking at that thinking, what on earth is that? And that's fine. What we're going to do is look at this triangle now, and we're going to label onto it the opposite side, the adjacent side, and the hypotenuse side. So it all starts with what angle we're being told about. So in this case, we don't know the value of x, but we know x is where it's at. We know that is the angle we need to work out. So from that angle x, we can first off say what the opposite side is. So the opposite side is literally dead opposite our angle x. Now the hypotenuse is always the longest side of the triangle, and that always ends up being the one opposite to the right angle as well. Now the adjacent is the side which is next to the angle x. Now the reason why I always do that last is because technically there's two sides, aren't there, next to the angle x. There's both the hypotenuse and the adjacent. But if we identify the hypotenuse first, then we're not going to get confused. So adjacent is this last one here. So now we need to look at that angle x and ask ourselves, well, which sides do we know already, or are we being asked about? And here I can see that I know the adjacent side and I know the opposite side. So for that reason, if I go to my so, ka, toa, because I've got the opposite and the adjacent there, I can say that tan x, which is the t of the toa, is equal to the opposite, which is the o, divided by the adjacent. And you can learn that as a triangle as well if you prefer, where the o is on the top and the tan x and the a are along the bottom. All of these are great options. You can see the way that I've written the soccer toa is very supportive of my triangle where the o is at the top. So here, let's substitute these numbers in then. So here we know that tan x is equal to the opposite, which I can see here is 1, divided by the adjacent, which is root 3. So now we've got a mark. Now the next thing that we need to do is to find the value of x. And to do this, we need to use our memory actually, because this is a non-calculator paper. Normally we would pick up our calculator, rearrange this equation, and say that x is equal to the inverse tan of 1 over root 3. Hit equals and we'd have our answer. But we can't do that here. There's some facts that we're expected to know, and one of those states that tan 30 equals 1 over root 3. Now that is just something that we need to memorise. So here in this case, through memory, we should know that x is equal to 30 degrees. And if you didn't know that fact and some of the other trig facts, then I suggest you get your books out, you make some notes, and you get memorising it most importantly. It was great work though, that was a really tricky question, so well done for getting through it.
Well done for making it to the end of this paper. I'm really, really proud of all of your hard work. What I suggest you do is go and watch the other paper 1 videos that we've got up, so you're really, really prepared for the exam. Ouch! This is why in some videos I'll explain scratches.